Last recap, we have tables, very similar to the one we just did in the Regents exam. Here's a table, answer a couple questions off the table. Using the formulas, you have three formulas, given, and or. And then are these events independent or dependent? That's what we're looking at tomorrow. All right. Before we get going with our review, I'll do a couple more questions. We did a great job yesterday, but I want to do a couple more with you as a group. Anything you want to ask? Your general questions going into tomorrow. It has been a whirlwind since last Thursday, I know, especially if you weren't here a day or two.
Just one thing on that.
Or three. What's up?
Just one thing on that last type of question. Like you said that there was kind of two ways to do it. You kind of like look.
Yeah, the look at the table, right, and then using the formula.
Okay. All right. Yep. And it doesn't matter which way.
Whatever gets the job done for you, Ellie. Cool. The correct job done. Others, anything else? All right, then. Here we go. 1 through 26, just like yesterday. Let's do a couple of them. 1 through 26. 19. 7. Table. We got a table on our hands. Which one is not true? Which one of these is not true? So why don't we just go through? Here's what I'd like. Here you go. Here's what I'd like to do. Forget what the answer is supposed to be. Let's just find each probability. Let's go through each of them right now. Can we find each probability? Ready? First one is probability of juice or chips. Juice or chips. You guys want to use the formula, or do you want to just get it off the table? Just the table? Can we do it just off the table? I'm a little worried if we do it just off the table, but we can formula or just off the table. What am I not on? I'm on the wrong 7. I'm on the wrong. Yeah, I can tell you how you're looking at me. This was from homework the other night. I was like, that one looked a little. There we go. How about a little texting right up your alley? Have we done this before? Have we done this one yet? Yesterday? All right, let me know if we did it yesterday, because I do different problems with you guys at first period. All right, it's a table problem. As you read through this, and or given, independent, dependent, what am I looking at for this one? Given, yep. Given. And I notice there's no total column, so I'm going to have to add stuff up on my own. Given the person's between 23 and 60. I already know they're between 23 and 60. I do not care about any other age group. So in the 23 to 60 range, how many total people do I have? Let's see. Three. What do I have? I don't want to even guess. 229. What do we already know? What do we already know? Given what? So what column am I? What row am I adding? The 23 through 60, and that's where I got 229. If I'm really cocky, I could stop here, right? Because there's only one up there with 229, right? But out of those 229, how many text over 50 messages? 157. Wait, what?
Oh, never mind.
Okay. Sarah,
Could you use the formula?
you want me to use the formula?
Yeah.
Okay, you got it. I don't. That's fine with me. So the probability, I have no idea. I'm going to write this. I'm just going to go put 50 given 2360. How about that? Is that all right with you, Sarah? All right. Now, Sarah, here's my question. Do you want me to use the actual fractions in here? Okay, so I'm on top. I'm going to say, what's the probability of 50 and over 23 to 60? Over the probability of 23 to 60. I'm just using the formula. Instead of A and B, I'm using these age and text messages numbers. Good, Sarah? Okay, here we go. So using my table, what's the probability I get someone who's texts over 50 times and is between 23 and 60? Crickets. What do you got? This is your show. Let's go. Over 50 and between 23 and 60. Okay, and you said you wanted to do the fraction, so 157 out of, now I got to add up this whole table now. Right? Not every number, but at least this, and this, whatever I got going here. You got that for me? Altogether, it's 3. I don't think it should be 312 altogether. Because now we're doing total. This is total. Listen, Sarah, you wanted to use the formula, right? So the formula says A given B is equal to A and B over B. So now using the table, I'm trying to figure out the probability of A and B, which is over 50 between 23 and 60. So there's 157 out of, now I got to figure out how many darn people are in the table, right? Because now it's out of the total, Sarah. So I got to figure out how many are in each age group, add them up. Or how many text messages were sent and add them up. Relax. Now I got the calculator in my hand. I'm not putting this down now. 456. Yep. That's what I thought. Sarah, ready? Over, what's the probability that they're between 23 and 60 now? Okay, so you're saying instead of just finding it from the table, do probability of A times the probability of B? Yeah. Okay, that's fine. We're stringing this out now when I could just find it from, see, I'm just trying to find it from a table and go. Okay, but yes, you could do probability of 50 times the probability of between 23 and 60. Okay, that's fine. We good? And then I'll just, at the bottom here, Sarah, should be 229 out of 456 for the probability that they're between 23 and 60. And then you skip and flip, or just put the darn thing in your calculator. And yeah, hey, the 456s are going to cancel out. And what's left? 157 over 229. We all right? Sarah, you good? Yeah. Okay, because I'm going to keep trucking here. 13, 1 through 26. 9. Oh. Okay. AJ High School. Yep. Students are allowed to enroll, and you can only enroll in U.S. history if you've taken World and European, excuse me, World or European. So 165 took AP, 66 took a World, and 66 took European. 33 took both. Okay. Determine the probability you select a senior who is allowed to enroll. You look at the end of this question and you're like, wait, what type of probability is it, right? And, or, given, I can't tell. But here's the thing, we got to go back to the beginning. When is a senior allowed to enroll? When's a senior allowed to enroll? If they've what? Taken World or European. Does everybody see? This is an or problem. Even though I know I always look at that last sentence, right? And I should look for the keywords or, and given. And it's not there, but, oh, wait a second. The only way I can take this course is if I've taken World or European. Or? Anybody? Or? Or? It's not, it's like, there's a formula for it. Or?
Probability of A.
Okay, hold on. So what am I going to calculate? The probability you've taken World.
Plus the probability that you've taken European.
You little Euro.
Minus the probability that you took both of them. Or and, yeah.
There it is. Everyone good while I'm calculating this one? Why I know it's an or. I know that, but it didn't say or at the end. That's where everyone gets confused. They always look at I do the same thing. I'm guilty of it. I look at the last sentence and I'm like, all right, where's and or given? I'm going. All right, world. Chances you took world?
Out of 825.
165 out of 825. Plus European. 66 out of 825. Everybody's good? Minus world and European. 33 out of 825. And then we're on our way, huh? I think this showed up on a Regents exam. This is an old Regents question. And let's see, that's 33. 33 is 132 out of 825. I totally butchered that. No, I totally butchered that. It should be more than 165. 198 out of 825. Does it reduce?
Yeah.
It does reduce because I can tell a 3 goes into both. Anybody ever learn that trick? How you know it's divisible by 3?
No.
Add up all the like 198. What's it add up to?
Wait.
11?
198 divisible by, if it's divisible by 3, then the whole number is, yeah.
Out of any big number?
So 825. What's it add up to?
15. Okay,
Divisible by 3.
Do what I just put that as a fraction in my calculator. Can it only be a 3-digit number?
I don't need it reduced either, Emily. Molly, what's your problem? We're trying to have some fun here, and you're just the party pooper. Go ahead.
I know we don't have to reduce, but if we want, can we, like, if we're doing the problem with like fractions, if we just like throw a decimal at the end, is that like wrong?
Better be the whole decimal,
Yeah, like
not your own rounded version.
Like if we wanted to put the decimal, like I think it's 24% as the decimal. Like, is that okay?
That's fine. But like I said, don't round it on your own, though.
Okay.
If it's like
So
0.246820, I don't want 0.24. That's not the actual probability.
Okay.
Sarah?
This might be a weird question, but can you just use A and B for this? Like instead of W and E, can you just continue using?
I don't
Why
care.
not have- Okay.
I don't care.
Well, I was concerned.
I get it. I actually thought about during this unit, like, say, let A equal this, let B equal this, but I thought that might have been a little bit too much. So, but yeah, that's fine.
Does it only work with 3-digit numbers?
No, works with anything. You add them all up. If that number's divisible by 3, the whole thing's divisible by 3. There you go.
No way. Is it always the numerator?
No. It's just any we're talking any number.
Oh.
Like if you give me 5, 6, 8, what's that? 19? Not divisible by 3. Look at that little trick there for you kids as you grow old.
I just know the 9 trick.
As you grow old. All good? Anybody AP classes? Never took one of my. Well, I shouldn't say that. I took one for about a month and a half and got
Me
out.
too.
It was I was blown out of the water. AP Micro,
I like
senior year.
Micro one. AP environmental.
I was like, see you later. Kids were just killing me. And that was my adventure in the AP land.
You sound nuts. I'm taking
Sorry.
One more together. Here we go. One more together. 18, 1 through 26.
That's Nora, but it's gonna be me. Number 1, because I don't get it.
Okay, I'm just gonna let you don't have to worry about something like number 1. It's just it's a word play.
Okay.
All those given problems we've done,
Wrong.
all those given ones we've done, they're called conditional. That's called conditional probability. Yes. Conditional probability is finding the givens. I'm not worried. I'm not going to be quizzing you on vocab tomorrow.
Number 5.
5.
No, number 6. Number 6.
I think we did.
No, we didn't.
Oh no, it's not.
We didn't do 6.
Can you let me have my moment?
Love you.
All right, little French fries here for you at the drive-through. Probability you get French fries 0.8. What's the symbol here for F? And, okay, so French fries and drive-in is going to be 0.456. What's the probability you get French fries given you go through the drive-through?
Wait, so given always goes in the denominator, right?
Correct. Correct. So are we using the formula here? Are we using the given formula here?
Yeah.
Okay, unless anybody sees something else, because there is a very shortcut method here, but I don't want to say anything.
It's independent.
Okay, where are we go? Just go do the formula?
Sure.
Yes, no?
I don't know any of the
Given equals.
0.456 be on the top.
Okay, here we go. So we're going to use the formula. F given D should be the same as, using my formula, F and D over
Oh, yeah.
D, right? We all good? We're going to run into a problem.
Yeah.
Probability of F given D, what am I putting on the top?
0.456.
0.456, but I got an issue, don't I?
We don't have.
I don't have the probability of D.
Oh, I thought.
Is now, this, sometimes it happens. Now, if I'm stuck, can I go to another formula to find my probability of D? Look at what I still have. I have F and I have F and D. Can I find D using any other formula maybe? The and formula, correct. So yeah, I do have to rely on two formulas here. F and D equal F times D. So now I plug in the 0.456 equals 0.8 times probability of D. You want to call an X there? Go right ahead. I need that value to plug into my original formula.
0.456.
And what's it become? Divide both sides by 0.8.
Yeah, can you just do that the shortcut way? Just do 0.456 divided by 0.8.
Well, how do you know this is going to be 0.8? Well, what do you mean?
I don't know. Wait, because.
I can't use the 0.8 here because the formula says you got to use you just told me use the given one, D.
Yeah.
But this is that. I just can't randomly plug in a different probability.
But isn't that what you're just doing?
But don't you say?
What do we end up with this one?
Don't you have to subtract?
It's 0.57.
0.57?
Because you divide
I
by.
think.
Wait, do you subtract 0.8?
Yeah, you would you
I
subtract
don't
0.8?
Well, why would I subtract?
What are you
It's being
even
multiplied.
Oh,
Yeah, so
oh,
yeah,
yeah.
So you still get 0.57.
I was
Come on,
thinking it was
guys.
No, you know, like
Does that
I get it.
Now this becomes 0.57 down here.
Yeah. Yeah.
See, so you could just do that from the beginning, 0.456 divided by 0.8.
You can, yes. That's what we're doing. You're using the formula.
Yeah, but
You're just.
I just don't want to guess that I got to divide. That's the thing. I want to make sure I'm sound. And the reason I'm dividing is because the formula says multiply. And what do we end up here with? 0.8.
Yeah. I think
But
we
since
should
it's
do it.
oh wait,
All right, here you go. Here you go.
Where did you get that?
I divided 0.456 divided by the 0.57 for probability of D we just found.
Yep.
Right?
Yes.
Okay. I said earlier, yes, there's a shortcut. I don't know if anybody picked up on it or not, but it did say F and D are independent. And you guys remember, there's two options for independent, right? Remember this option? Probability of A given B should be equal to what if they're independent?
the probability of A.
Everyone remember that? That's the test one test that it needs to pass. Well, look now. Probability of F given D, that's what we needed to find. If they're independent, ready?
Yeah.
If they're independent, which they are, they tell me this should be equal to what? The probability of? What did it tell you in the problem? 0.8, right? So that must mean F given D is also 0.8. Not needed, we figured it out algebraically another way, but if we saw that they are independent and knew the one of the tests, we were a little bit quicker.
I think we should do one more.
We should do one more.
Can we do number 8?
Just keep going.
Number 8.
Sure, we can do one more. I got to take hands off here in a second. 2. Number 8 it is. A lot of words here, huh?
Yikes. I'm looking
Yeah.
crazy right now.
No, I didn't pick that one.
That's what
Jenna.
I'm crazy.
Okay, number 8. Yeah, there's a lot to read. You see 0.8 and you see 0.85. Right? You see that. All right, I got to realize what it's for. And determine the probability a randomly selected resident opposes spending money on plumbing issues and, all right, at least I know it's an and problem. And don't even think about just multiplying those two and you think you got it. You have no idea what those two mean yet. We did not read through the problem. All right? So here we go. What's the 0.8? Resident of a housing community opposes spending money on plumbing. I don't know. How do you want to write? I don't know. How do you want to write that?
I just wrote P plumbing.
And
You're doing P for P of P? That's what you're doing to me here?
Yep, I did that before.
So that's the plumbing one, right?
Yep.
Sarah?
Doesn't it say on improving walkways given that the residents
Yeah, that's the next
oppose
sentence.
spending money?
I'm not there yet. That's not, I just said, we're going through right now and describing what 0.8 and 0.85 means. All 0.8 means is you favor plumbing. No given yet, right?
Oh, yeah.
That's my question though, right? The question is this is an and question, Sarah. That's what I'm saying.
So it's not a given question.
Where is the word given in the question? Determine the probability.
No, go up.
I know that. I'm just not there yet. I'm asking you what type of question this is. This is an and question. But I know there's a given in one. I know there's a given up there. But it's not a given problem. All good?
Be doing all these.
So would you,
Now, what's the 0.85 going to mean?
Walkways given.
The probability you favor spending on
Yeah.
walkways, given you oppose plumbing.
favors?
Favors?
How about just W for walkways?
Yeah, that's what I.
Walkways,
It's fine.
given
It's fine, guys.
plumbing. I'm staying standard here. And that's equal to
Oh,
0.85. Now, I'm at the end of the problem. What's it want me to find?
Plumbing and walkways.
There you go. Find plumbing and walkways.
So wait, they're both not for plumbing.
One's for walkways, one's for plumbing.
Okay.
Oh, I'm about to kill this.
Okay, here it is in symbolic form. We finally broke down this darn problem. In symbolic form, here's what it is. You know P is 0.8. W given P is 0.85. What's WNP? What's up, Molly?
I have an idea.
Okay, well, first of all, how am I going to find? Let's just start here. Do I have enough information to find
Yes.
plumbing and walkways?
Yeah, if you put it into another equation.
Well, hold on. What is this equation I need here?
Oh, for the normal and equation?
Yeah, what's the and equation I need, everybody?
P of P. P of P times P of W. You don't need to do something else. And I know what this is.
Now that I look at this, I probably shouldn't have approached it this way, but
You can use the given equation to find the and. So smart.
because I don't know if we're going to be able to. I know we know P of P is 0.8. I don't know if we're going to find the W though.
Oh yeah, how are we gonna find W? The given equation?
Okay, let me just here you go. Ready?
Have a W.
All right, enough, please. Ready? Okay, here's what we thought. We need and, so I multiply them. I know this is 0.8, correct?
Yeah.
All right, so now I got to figure out a way to find W. Oh boy. I don't know if I'm gonna do that or not.
Nope.
Because the only other, ready? The only other thing is the given one. And that's not gonna involve W by itself. So I don't think we're gonna be able to find the probability of the walkways. Right? Everyone agrees?
Girl.
There's no way I can find the W. Are we all in agreement?
Yes.
Okay, so probably not gonna use this formula then. So there's gotta be another way around this. I was given W, given P. What should that be equal to? I know it already, it's 0.85, but what's it equal to? What's the formula say?
P and W. on
This
the
should
top.
be W and P over P. Everyone see how I'm just gonna have one missing value here?
Yeah.
Because P is 0.8 already, and now you're just left with W and P, which is what I'm looking for. So I'm using the given formula to get here.
Okay.
I thought I was right at the beginning using the AND formula, but I'm like, this is totally useless. There's no way I'm finding W. So I used another formula that was given.
So how do you know when a person like this which one to pick?
Trial and error. One of them, Emily, you're going to have enough information for. The other, no shot.
And then do you just constant?
Then I just cross multiply. So W and P. And we end up with, I don't have my,
0.6868.
That was a toughie.
Bing bong.
Bing bong.
Those.
I know you're tired of hearing this, but it all comes down to formulas, right? If I don't know my three formulas, I'm not going to do very well. At least if I have them in front of me, I can at least say, can I plug it in here? Which formula can I use where I only have one missing variable? And if I have two, can I use another formula to fill one of them in? All right? All right. We're done up here. You guys are going on your own.
We're done.
You can call me over if you have any issues.
You have to memorize these for the weekends too.
Yeah, that's not. Remember, the only thing they're going to give you